Okay, good morning. So let us continue our lesson. I want to write one example here so that you can think about it yourself, and then we continue the lesson. Okay, so let me write an example. The line 3x minus 5y plus 17 equals to 0 passes through the point A with coordinates 2t minus 3 and t plus 4. Determine t. Yes, I want you to solve this problem. Okay, what is the value? Did you get the value for t? Yes? 12. Let us calculate and see. According to what I have here, 12 is correct. Yes, 12 is the correct answer. Okay, so let us solve this problem. How should I solve this problem? This line passes through a point with these coordinates. So then I told you that a point lies on a line if and only if the coordinates of the point satisfies the equation of the line. So it means that if I replace x in the equation with the x coordinate and y with the y coordinate, this equality should be a true equality. Yes? So then it means that I will do the same thing. So I will write 3, and then instead of x coordinate I put 2t minus 3, and then I have minus 5. Instead of y I have t plus 4, and then I have 17 equals to 0. Then it means that I have to solve this one simple equation, and that is a Math 1C problem actually. So you multiply that, it becomes 6t minus 9. You multiply minus 5 in, it becomes minus 5t minus 20. 17 equals to 0. Don't speak loudly, please. So 6t minus 5t is t, and then minus 9 minus 20 minus 29, and then 17 is minus 12 equals to 0. Then it means that t is equal to 12. Yes? So that is the answer that you have to provide for this problem. So let me ask you another question. So 2 points A with coordinates 4t minus 3 and 2t minus 1. 2 points A and B. B is with coordinates 5 and 9. Lie on a line that is parallel to the x-axis. Determine t. Yes? So I want to give you time to solve this one. 1 or 2 minutes is enough. Okay, what is the answer for this problem? What is your answer, Leon? 2. What is your answer? 5. Apparently 5 is in the book. So let me see. So 2 points, this and that lie on a line that is parallel to the x-axis. What is the meaning of this? If a line is supposed to be parallel to the x-axis, we call that line a horizontal line. Yes? And we know that the slope for a horizontal line should be 0. Yes? So what we can do, we can say that, okay, let me calculate the k-value, the slope for the line which passes through these points, yes? So the k-value, let me write an index AB. By this symbol I mean the k-value for the line that passes through A and B. That's my convention here. So then it becomes, according to the formula, it becomes y of the first number, y minus the second one, and then you can write this. The difference between y coordinates divided by the difference between x coordinates. Yes, so this, if I calculate that one, so you really don't need to calculate, yes, this is the formula. But then you want that line to be horizontal, so it means that AB is parallel to the x-axis. It means that the k-value of AB should be what? 0. And then this is a fraction. If I ask you when a fraction becomes equal to 0, that a fraction becomes 0 if and only if the denominator is not 0 but the numerator is 0. Yes? So it means that I have to be careful. It means that the numerator should be 0. So it means that the y coordinate of A should be equal to the y coordinate of B. Yes? And that is it. Y coordinate of A is 2t minus 1. Y coordinate of B is 9. And then you solve this very simple equation. So the algebra in analytic geometry is not complicated, but you need to understand the connection between geometry and algebra. So 2t becomes 10, and as you mentioned, t is exactly equal to 5. Yes? Is that clear? Let me ask you one more question here. Example, show that the points A with coordinates 5 and 7, B with coordinates 4 and 3, and C with coordinates 6 and 11 all lie on the same straight line. Okay, so I want to wait for you. So let me just tell you, if I give you 2 points, it's always guaranteed that 2 points lie on the same line. Yes? Because if I give you 2 points, then you can always draw a line passing through them. But if I have 3 points, there is no guarantee, because might be 2 of them are here, the third one is here. There is no way that they lie on the same line. But we want to show, no, for these particular numbers as coordinates, these 3 points definitely lie on the same straight line. You want to motivate why this is true. So let me just pause the recording, give you time to think about it. Okay? What is the strategy to solve the problem? Even if you haven't done the details, no problems, but you can just tell me what is your strategy to solve the problem. Yes?
We need to show that all of the points have the same k value and is same y-intercept, and x-intercept.
You cannot show that, because you know that. You cannot say a slope of a point. What do you mean by slope of a point?
I mean, show the k value is the same for the points on the line.
Okay, you have to be more explicit. Anyone else? Better explanations?
I mean, like, yes, my strategy was just show that A, B, and B, C both have the same k value.
Is it K? What one?
No, the same. I mean the formula. What was called the K formula or
Yeah.
K form. I just tried to convert it into that and show that both of them fit into that formula, like both the lines.
Yes.
Yes.
But my strategy is, instead of checking it 2 times, I think, don't you think it is better to find an equation for the line passing through A and B? For the time being, forget about C. Yes. How many lines are there that passes through A and B? How many lines are there?
1.
Exactly 1. Yes. So that is, I can write an equation for the line that passes through A and B. But it is not guaranteed that this line also passes through C. But then I check the coordinates of this point into the equation that I found. If it works there, it means that that is also on that line, which is the unique line. If it doesn't work, it means that this is not the case. Yes? Of course, what you said is also probably correct. So you want to compare the K values. So you are saying that if the 3 lines, if the 3 points are supposed to be on the same line, then this is A, this is B, this is C, for example. You want to calculate the K value for AB and the K value for AC, and then you say that the K values are the same, so then they lie on the same line. That also works, I think. Yes. So, but let me follow my strategy here. So if I want to do that, I will try to write an equation for the line passing through these 2 points. Okay, so what I have to do, I have to find the K value of AB first. So this is Y of A, Y of B. So the difference between Y coordinates, the difference between X coordinates in the same order that I have chosen for the numerator. So Y of A is given to be 7, Y of B is given to be 3, X of A is given to be 5, that is 4. So then answer becomes 4. 5 minus 4 is 1, 7 minus 3 is 4. So K of AB is this one. Then I remind myself about the 1-point formula, yes? Using this 1-point formula, I, for example, take this one as my point, and this is my K value. I replace them here, and I will find an equation for the line that passes through A and B. So how? I would say that this is Y minus Y node, which is what? Here, for example, 7. K value is 4. And then I have X minus X node, which is 5. Yes? This is an equation for AB. Yes? And then let us simplify that. So it becomes Y equals to, I multiply it by 4, 4X. This becomes minus 20, but then I move minus 7 there. It becomes positive 7, minus 20. It becomes minus 30. If I ask you what is this in this box, you would say this is an equation for the line that passes through A and B. And now I want to see if this is true or not. Is it passing through the 3rd point or not? According to the problem, according to the claim of the problem, it should be the case. So what does it mean? It means that I check the coordinates of this point on this line to see if it is true or false. So instead of Y, I put 11. I put a question mark. Instead of X, I put 6. So it becomes 4 times 6 minus 13. Yes, but this becomes 11. What is, this is 24 minus 13, which is 11. So that is true. Yes, so this means that the 3rd point also lies there. But let me follow this strategy of K values now. So what you said, we calculate the K value of AB and we calculate the K value of AC. Yes, that's also good because we haven't studied that yet, but this is very easy. If the K values are the same, there is no guarantee that the lines are the same, because if I have 2 parallel lines, the K values are the same. But if they are parallel and they have 1 point in common, then they have to be on the same line. Yes? So that is also a second strategy. So let me change my color so you can just consider it as another problem. So I calculate K of B, K of AB, which I have already done. So this is the second method. So you get 4. But I also calculate K of AC. So what is K of AC? Y of A minus YC, X of A minus X of C. So Y of A is 7, Y of C is 11, and then X of A is 5, X of C is what? X of C is 11. Oh, sorry, I made a mistake here. No, x of c is 6. So the other one, this becomes minus 4, but this becomes minus 1. And then finally it becomes 4. So you see that the k values are the same, but you have to express it in words. You should say that because k values are the same, and then this line and this line has the point A in common, so then it means that they have to lie all on the same line. Okay. But now let me increase the level here. Here I gave you 3 points and you check that they are on the same line, but let me change the problem to this problem now. A little bit different. So example, determine n such that the points A with coordinates 4, 9, B with coordinates 3 and 5, C with coordinates n plus 1 and 3n, all lie on the same line. By the way, I told you that in this chapter when I say line, I always mean a straight line. So the strategy is exactly as before, but here you want to fine-tune this n. There is no guarantee that these 3 points lie on the same line. You want to adjust n in a way that they become on the same line. Okay? So I will pause the recording and I wait for you to I want you to find the exact value and I can check it against the answer in the book. Yeah, please pay attention and then try to solve it carefully. Okay, what happened? Yes?
I got n is 3.
Yes, thank you. That's correct. So let us solve that. Determine n such that the points all lie on the same line. You can follow that strategy or this strategy, it doesn't matter. Okay? So for example, let us choose that one here. So what I am supposed to do, I calculate k of AB here, which is YB minus, let me write it the other way around this time. You see, when I start with B, I have to start with B in the denominator as well. So as far as I respect this, it doesn't matter which one you write first, which one you write second. I intentionally wrote one in this form, one in this form, but they are the same. Yes? So what is YB here is 5, what is YA is 9. Divided, XB is 3, XA is 4. So if you calculate, it is minus 4 in the numerator, and then you have, so it is minus 4 in the numerator, and then you have minus 1 in the denominator. So the K value of AB is equal to 4. Yes? And I also calculate the K value of AC, for example. Then this becomes YC minus YA divided by XC minus XA. But XC is n plus 1, YC is 3n, minus YA is 9, divided by. XC is n plus 1, minus XA is 4. Yes? So that's very interesting this happens. I couldn't see that. So and let me see, but I didn't anticipate that this will happen by this way of solving. But this becomes 3n minus 9, then it becomes 8 minus 3. Yes? Okay, it is hard to understand it from this perspective. Let me ask you one question. So you have the K value of AB to be 4 and the K value of AC to be this expression. Yes? And then, if I want to solve the problem, this K value should be equal to this K value, yes? So then it means that 3n minus 9 divided by n minus 3. So let me check my calculations. Y of C is 3n minus y of A is 9. That was correct. X of C is what? N plus 1. and then x of a is 4. So if you subtract them, it becomes n minus 3. That's correct. And then you want to make it equal to 4. Yes? Okay. And if I solve that equation, how should I solve this equation?
N cancels.
Pardon?
N cancels first, right?
No, it n doesn't cancel here.
Oh no,
Yeah. But how do you solve this? Do you remember, I told you, remember, this is an important tool in your hand. If you have two fractions equal, this happens if and only if I multiply these two, a and d, it becomes equal if I multiply these two, yes? And then instead of 4, you can imagine 4 over 1 and use the same rule. This multiplied by that, it becomes 3n minus 9 is equal to this multiplied by that is what? 4n minus 12. And then I move 4n to the other side, it becomes 3n minus 4n. And then I move 9 to the other side, it's minus 12 plus 9. This becomes minus n, this becomes minus 3, and then as I have predicted correctly, the answer is 3. Okay, but let me ask you this question, because usually if you are good in algebra, you do not stop here. Yes? So let me change my color. This is the correct answer, but let me continue, because I have trained my brain so that when I can simplify something, I simplify it. Okay? Then you will be in trouble in this case. And I want to ask you why. Because if I am doing everything right, in mathematics, the answer should be the same. Okay? But now, can I write this expression in the numerator like this?
Yes.
Because if I multiply this back, it becomes exactly the same expression. And then I have n minus 3 here. And then I can simplify n minus 3 with that n minus 3. And then I get answer 3. Yes? And then the k-value of AB is 4. The k-value of AC apparently is 3. And then I am in trouble now. Because I want to make the k-values the same. But it is not possible to make the same. Because my lever at my hand was fine-tuning using n. But unfortunately that n is cancelled. And I cannot force 3 to be equal to 4. So what is happening? You see, apparently I haven't done something wrong. Yes? But if I continue in this way, then I am in trouble. Then you will say that it is not possible to find n in a way that these 3 points lie on the same line. But if I solve it in that way, I will get n equals to 3. Of course, you can use Geogebra and try to see that which one is correct. The answer 3 is correct or being impossible is correct. But I can guarantee you probably that 3 is correct. Okay? Why I have problems if I want to do in this way? Apparently I have done everything right. At least you need to understand either that should be right or this should be right. They cannot simultaneously be right, yes? But what is the problem and which one is right then? Yes?
Well, if n is 3, then 3 minus 3 is
0.
0.
Exactly. So the cancellation, when I cancel something from the numerator and the denominator, I am implicitly assuming that that number is not 0. Yes? Otherwise, I am not allowed to simplify. This is crucial. And then, because I was so unlucky in this case, the correct answer is exactly 3. And for the 3, this number is 0. So I am not able to divide that. So be careful. If you want to divide, implicitly you are assuming that that expression is not 0. But there is no guarantee yet, because I don't know n. I don't know n, so I don't know n minus 3. It might happen that n minus 3 is 0, and that was one of those special cases that the correct answer is 3 and n minus 3 is 0. So if I want to do this, I would say that if n is not equal to 3, look, you should, when I simplify this, I am assuming that n is not 3. If n is not 3, there is no way that they have to be the same. But if n is not 3, if n is not 3, then I can equate them, yes? So let me see. If n is not 3, then the k-value of AB is 4, the k-value of AC is 3, and it is not possible to make them the same. Okay? So it means that n should be 3 if this is going to happen. But is it guaranteed that if n is equal to 3, this will happen? The answer is yes. Because when n is equal to 3, the coordinate here becomes 9. And this line automatically becomes a horizontal line, yes? But then let us look, let us see. Might be the person who has designed the question. So if n is 3, what happens, by the way? It is 4 and 9. Yes. It is a very interesting question. I didn't anticipate that. So let me see what's happening here. If n is 3, this is 9, this is 4.
Yeah.
So what is happening?
So it's the same point.
It's the same point. The person who actually designed the question didn't care about this. They just solved the problem. So I want you to understand, I'm just following the numbers in the book. But you see, that is not also the solution. Because if n is equal to 3, what happens? There are not 3 points. Of course, I would say that yes, that answer is correct, because in that case, this third point is actually the first point. Yes? But that was not the way that we were thinking. So if you think about the problems deeper, you can discover things more. Yes? Is that clear? So I would say that I will accept that n equals to 3, but it is not, because if n is equal to 3, the third point is not the third point. It becomes this point. And then I have 2 points, and of course 2 points are always lying on the same line. Yes? But it was crucial to understand what is going on. Yes?
So a line between 2 points that are on the same, in the exact same place, is there a name for anything like that? Or is that even a line?
So if I want to, so if I want to imagine, these 2 points are fixed points, and I have a line. Yes? And then if I want to make it on this line, there is only one way, but how can you imagine that? Yes? There is only one way to make it there, yes? And that is by choosing it to be the same point. Yes? So it means that I need to understand what is the trace of this point when n goes actually, yeah.
Where it's like the line AC, is that an actual line? Like, right, is that like...
No, that's the problem, yes.
So
in that case, that's not actually a line. It's just infinitely many lines. So that is, it's not, what I'm saying is that if n is not 3, you see, if n is not 3, then I am in trouble because the k-value becomes 3 and the k-values become 4. It is not possible to make them the same. And if n is equal to 3, even though I am able to make them the same, but then I will not have 3 points. I have only 2 points. So I would say that this question is not that a good question that was written in this book. Yes? Okay. So now let me. And by the way, if you don't mind, let me check this problem from the first strategy point of view to see what happens. What is your prediction? If I follow this strategy, finding the equation of these 2 lines and asking for n, let us see what happens. Do you predict that you will get 3 again?
We did, but we didn't get 3.
So what did you get? Okay, let me follow that, because this is always very instructive if you see the problem from different perspectives. Yes. So let me do that problem. So if I want to do that, I already have k-value of AB here, and if you don't mind, let me use A. So what happens? It becomes y minus the y coordinate. I'm using this formula. Yes, I am using the 1-point formula. So instead of y naught, what do I write? I write y minus the y naught, for example, for A point, it is 9. The k-value is 4, and then I have x minus 4. And then if I ask you what is y, let us simplify it in our head. This becomes 4x, this becomes minus 16, and then I would have minus 7. Do you agree? That would be that equation. 4x minus 16, and I move this on the right hand side, positive 9 minus 16 is minus 7. Okay, and then I put the coordinates. This line is supposed to pass through that one. So instead of n, I put 3. Instead of y, I put the y coordinate, and instead of x, I put the x coordinate. But this will give you the answer again. Yes? So this becomes 3n. I multiply this, it becomes 4n. 4 times 1 minus 7. And I move this to the other side, it becomes minus n equals to minus 3, and then you get 3. Yes? But so you see that if you just design the questions blindly, they might not be a good example. So in this case, we will not have 3 points, we will have only 2 points. If you don't mind, let us demonstrate it using GeoGebra. I'm also curious to see what happens, okay? Let me ask you, this is a harder question that I want to ask. Can you anticipate where the point C will move if I start changing n before seeing the demonstration? So the point C, what was the point C, do you remember? So let me just turn it off again. So I want you to answer this question. You see, this is a harder question, of course, and I want you to, we can consider it A-level question or whatever. So you see this point is fixed. You can find its location exactly. This point is also fixed. You can find it exactly. But this point is not fixed. Depending on what value I choose for n, the location of C will change. Yes? Now, my question is this. If you use GeoGebra and try to start changing the values for n, this point C will move. This might move on a circle. I don't know. It might move on a very strange curve. It might move on a straight line. You understand what I mean? Because we don't know. We want to find the trajectory of this particle when n starts changing. Because that point, so this is, by the way, if I want to write it, if I want to express it in mathematical terms, I'm asking you about the locus of the point C. So it means that where are the locations of the point C if I start changing the n? Because the point is variable. It might be here and then jumps here, then jumps here. So that is not a straight line. Might be if I do them smoothly, I see that they are drawing a curve for me. What might be this curve goes up and down, or I don't know. It might be a straight line, or it might be part of a circle, or it might be a random curve. Yes? Can you anticipate what would be the trajectory of the point C if I start changing n?
It goes up exponentially.
No, you need to have a reason for that.
Because the y coordinate of C is 3 times n. Meanwhile, the x coordinate is n plus 1. So
okay, let me ask you, do you think the trajectory is a straight line or a curved line? Curved line, yes? What is your anticipation? Just answer this question. Do you think that locus of point C will be something curved or a straight line? Yes?
I think it would be a straight line.
Yes?
Because if we imagine, if we imagine a linear function, then we could say that the linear function describes the locus of a point whose coordinates is x as the x-axis, as the x-coordinate and 3x.
No, that is not mathematical argument. That is just your intuition.
Yeah.
So Ali's intuition is that that would be curved. Your intuition is that, but none of you could defend yourself properly right now.
Not very well, at least.
Yeah? Yes, Haya? Curved or straight?
Straight.
Can you say something about it?
So, I don't have an explanation with words, but if you use different values for n, the y coordinate always increases by 1.
So because the y coordinate and the x coordinate are simultaneously increasing,
Yeah. So
but one of them with an I add 1 unit to one of them, but I multiply the other one by 3. So you see, every time the x coordinate is 1 more than the n I choose, but the y coordinate is 3 times larger than n I choose.
So it's a straight line and the y-intersect is -1. Or
If that's a straight line, I ask you, if the people who are thinking that this is a straight line, tell me what is the equation of that straight line, because straight lines are at the level of your knowledge. If this is supposed to be a straight line, find an equation for that straight line for me. I want to give you time a little bit to think. This will improve your intuition and the way that you argue in this analytic geometry, yes? So, my question is that, if people believe that this is a curve, okay, that would be above our lesson. Forget about finding an equation for that curve. But if you believe that this is going to be a straight line, we are studying it, we know everything about straight lines. In principle, you should be able to find an equation for that straight line that you are claiming. Yes? I want to do this before seeing the demonstration. So I want to bring this up, so then remember that. Please write it down somewhere in your notebook so that if you forget, just have it in front of your eyes. Yes? C has coordinates n plus 1 and 3 times n. Point A was coordinates 4 and 9. So 4 and 9. So that was my point A. 4 and 9. Am I right here? Yes. That is my point A. My point B was 3 and 5. 3 and 5. This is my point B. Okay. I will not write point C for the time being. Okay, we can write it. Yes. But of course, what will happen in GeoGebra if I type the coordinates of point C?
It will give you a slider.
Yeah, it will give me a slider because that is a variable there, yes? So that I can vary the value for n. Okay, so let me just do that. Hopefully, so point C is equal to n plus 1, and then I have 3n, yes? So that would be a point, so it will create a slider. For the time being, C is here, because what has been chosen, what is the value chosen for n? You see that n is equal to 1. Yes? If you put n equals to 1 here, then it becomes 3, sorry, it becomes 2 and 3. And this is why, for the time being, you see the point C here. Yes? It is 2 and 3. But now, what do you think will happen if I, for example, I think that's a good range, from -5 to 5, and then good point is that the number that we want is in this range. Yes, do you remember we calculated n equals to 3. We want to demonstrate that. But here, what happens if I start varying this? So let me hide this point for the time being and make it negative here. Yes, and then open it up. You cannot see point C right now because it is -4 and -15. It should be somewhere here, yes? So if I put -5, the lowest one in this range, here it becomes -4 and it becomes -15, and if you find it, it is somewhere there. Now, if I play this, okay, this will start going from -5 to 5, and then you see that this point C starts moving. And then I can, of course, I think we can do this in GeoGebra. I right click here and I ask GeoGebra to show the trace. Okay? And then you will probably see what will be the line. Okay? But I want you to see before that. I want you to tell me what is happening before that.
But using the 1-point equation or
could you find an, if you are claiming that the trajectory would be a straight line, could you find an equation for that straight line?
I mean, just what was it called, the 1-point equation?
No, because you need to exactly know what you're supposed to do. Okay, let me show you what will happen and see what is correct. So it seems what?
Straight line.
It seems a straight line. So the prediction of a straight line apparently is guaranteed, yes? So coming back, making it better. So it is probably, by this time, of course you cannot be sure that is a, because it might be a circle, but it is a very, very, very huge circle that you cannot see the deviation from straight line. Exactly planet Earth, yes? It's curved, but we don't know. So there is no guarantee yet. Our eyes are saying that this is a straight line, but it might be a very, very huge circle. We cannot see the deviation of this. But apparently, if everything is fine, this is a straight line. Yes? And now, if I ask you, just let me pause this. If, assuming that this is really a straight line, can you find an equation for this straight line by this graph? Do it.
Say no more.
Yes, you see, assume that this is really a straight line. By the values you see here, I want you to find an equation for this. Then I will tell you that, yes, this fly is actually very, very annoying. They are very, very big, by the way. Okay. So let us come back here. So find an equation for this line. If this is a real line, please find an equation for that by seeing the information on the picture. Okay, I will give you a little bit of time. Okay, so you are reading your equation, but can you simplify and read it? So always try to simplify that.
Okay, I've simplified. It's y equals to 3x minus 2.
Y equals to what?
3x minus 3.
3x minus 3. So let me, by the way, we didn't see the other, so let me just start moving it manually by hand. We predicted that when n becomes exactly equal to 3, these will go on the same line at A and B, but this never passes through this.
Never passes through it.
So might be our calculation is wrong somewhere. Because you see, I am changing the values for this C, and apparently they are not passing through that.
2.5.
Yes? So what's happening? You see the point C is moving. Yes? And it becomes exactly the same A at some point. Yes? Do you think we calculated something wrong or not?
No, but why?
So here n is equal to 3 and you see what happens. C exactly lies on A. But that is correct, yes? Because now, if I ask you, are these 3 points are on the same line, you would say yes, the line that passes through C and B, or A and B. So that the calculation was not wrong. But that was not a very good question. At least we were able to find a better question out of it. Okay? Could you anticipate that this is going to be a straight line? And could you find an equation for this straight line if this is a straight line? Yes? Okay. So now let me turn this off and come back to this and try to find that equation. Okay, so let me make it clear again. Okay, so if you want to find an equation for this line using the graph, what do? You read the coordinates here and you read the coordinates here. And then you have 2 points of your line. Using the method that we have learned so far, we can write an equation for this line. Yes? So let us just do it on the board now. So the point C is n plus 1 and 3n. Yes? According to Geogebra, we saw that the locus of these points intersect the x-axis at point 1 and 0 and intersect the y at -0 and -3. We want to find an equation for this line. This is a very simple problem for you by now. So I would say that this is, let me call this point, I want to find the k value. The k value is the difference between the y coordinates, 0 minus -3, divided by the difference between the x coordinates. So it becomes 3. That's the k value. And then I use 1-point formula to find an equation. If I put 0 here, it becomes y minus 0, the k value is 3, and x minus 1. So as you predicted, the answer is correct. So that is an E-level question for you. I give you the graph of this, and then I ask you to find an equation. But the problem is harder. Yes?
Why are we allowed to use Geogebra to find the points? 1, 0 and...
No, that's a different question. I ask you...
Or are we just... Are we given 1, 0? Or...
No, you are missing the logic. I design another question inside another question. I am assuming that, forget about this, assume that this question is given to you in the exam.
Okay.
You can read the information and write the equation.
Okay.
Okay? But there is a reason that I did it, because now I want to do this independent of the picture, and I want to see that we get the same answer. So it is possible for us to predict the locus of this point is a straight line, and on top of that, we can find this equation without any demonstrations. That is my question for you to ask. How can I do that? Assume that you want to find this equation, but you don't have GeoGebra to show you the locus. You just look at here, do some algebraic calculations, and then you want to get this one at the end. Yes? You want to answer, Rasmus?
Yeah.
Yes?
And we can...
Keep quiet, please.
We can, in principle, get the same problem by just choosing 2 points, by just choosing 2 arbitrary values for n.
No. Because this means that you already know that the locus is a straight line. Yes. If you can prove mathematically that the locus is a straight line, then your method will work. But still, we don't know that yet. We want to show that the locus is a straight line. So do you have any suggestions for that one now? Yes?
Isn't it the case that a curved line always have like an exponent
Yes.
in the...
But that is not related to this. For x, in the final form, yes, you are right. But because of that, you cannot say because this is first degree. I can also, that's a good question. I will come back to it. Okay, but for the time being, you are right. If I get something which is a higher power here, then that is not a straight line. Yes, because we know what are the equations for straight lines. Okay, so the way that you have to solve this, I want you to learn this. I would say that, okay, I want to find an equation for the locus of this point. I would say that let x and y be a point on the locus. Whatever it is, I don't know. But I know that x and y is on the locus of this point. So what does it mean? It means that there exists, this symbol means there exists n in the set of real numbers. This is a fancy way of saying there exists n belonging to the real number. So it means that there exists a real number such that, this double dot means such that x is equal, y is equal. Can you fill up these gaps for me? I am assuming that xy is a typical point on the locus. Okay? Then I am claiming that because of the form of the point, there should exist a number in the set of real numbers so that x is equal to question mark, y is equal to question. Yes?
Shouldn't it just be n plus 1 and 3?
Yeah, exactly. That's exactly the case. Yes? So, if this point is on the locus of this point, of these points, then it means that this should have the same form. X should be n plus 1, y should be 3n plus 1, 3n. But I want to connect I want to find the relation between x and y. Here, this is relating to n, y is also relating to n. I want to relate to x and y together rather than relating them to n. Okay, but that is easy. For example, I can calculate n from this equation. This becomes x minus 1. And then I can put it here. Yes? So y becomes 3x minus 1. And that is exactly what you found. So you see y is equal to 3x minus 3. So, in this way, I proved two things. Actually, I proved that this is a straight line. And then I also found the equation of the straight line. Is that understandable? Now I want to challenge your intuition. Okay? I keep this one, but I increase the power. Now predict, is the locus still a straight line or now it becomes a curved? Answer that, yes?
Well, I think it's a curve and it increases exponentially.
Because of?
Because it's exponential.
It's because of power 2, yes? So your prediction is that now the locus here is a curved line. Is that right or not?
Yeah.
Okay? Let us demonstrate it using GeoGebra. And then after that try to analyze that. It's a little bit counterintuitive here. I want you to see that. Okay? So let me just turn this on. So remember, I increased the power. Instead of power 1, I made it power 2. Yes? Now, I start typing this new form. So C n to the power of 2 plus 1. And then I will have 3 n to the power of 2. Yes? After pressing that, it will create a slider as before. So that is my point. So where is it, by the way, now?
It's
So there is a complaint going on somewhere, yes?
oh yeah, you should say that C is equal to.
Ah, okay, I should write C. So what can I do now?
Just
Put equality here, yes?
Yeah.
Yes, good. So that is my point now. Okay, so let me turn it off now. Okay, we can start doing that demonstration here. So let me go here and ask GeoGebra to show the trace. Okay, so what's your prediction? Curve or straight line?
Straight line.
What?
Okay, we can vote. Curve or a straight line?
Straight line.
or
So why do you say a straight line, Ali?
Because the n value increases on both x and y, same as before.
That's intuition, yes?
Well, it also increased by 3.
Are you ready to bet on your life for that?
no.
Yes?
I'm gonna guess it's curved.
It's curved. Let us see.
Okay. What?
Yes.
It is straight. Or maybe just a huge circle.
It's coming back.
They can't just
Don't worry, and it's making it better and better. But something strange happened. Could you predict? It doesn't go down.
Yes, because it's to the power of 2,
But
so it
it's
can't be negative.
So now you realize still it's a straight line.
And it's the
It
same.
was counterintuitive because of this, and I hope that if you know mathematics, you should be able to predict that this particle, if you see physics, it's a particle, for example, you see that first of all this velocity, the speed of the particle is changing. It was not the case before. You probably studied these things in physics to see why this is a speeding up, speeding down, acceleration is something like this. But there is something that you could also predict, but at this level. Later you will learn how to predict the velocity and acceleration later. But here you could predict that this comes to a halt. It cannot go below. Yes? So first of all, we want to understand this. Why this is happening? Why this is still a straight line? This is not, by the way, a line. What is the name for this? In geometry, I told you before. It's called a ray.
Okay, ray.
A ray starts from somewhere, goes to infinity in other direction. Yes, that's a ray. So it is not a complete straight line, it's a ray. Starting from one point going upwards. So, but let me try to understand this again using mathematics, not demonstration using GeoGebra, okay? And I want to tell me why. Could you predict? By the way, what is the equation of this straight line? the straight line that this is lying on one part of it.
By using the same strategy
Yes,
as before,
exactly.
it's the same equation.
Exactly.
But that does not feel right because c never goes into the never becomes negative.
Yes, exactly.
Why the
But
equation?
no, my question is that, first of all, this is not a straight line. This is one part of the straight line, but that is exactly the same line. That is one part of exactly the previous line. Let us understand it from mathematical point of view, and we have to finish the lesson 5 minutes earlier because they need the aula. Just let me finish it. So what Rasmus mentioned is completely right, because now we have to use the same strategy here. Yes? Okay. So again, I have given you this point, and I want to find the equation for the locus, or the locus here. So what I would say that let x and y be a representative point on the locus. Because this lies on the locus of this point, so it means that there should exist an n in R, so that x is what? N squared plus 1, and y is 3n squared. So x is related to n, y is related to n. I want to relate x and y together. Yes? So what I can do, I can use the same trick. I move 1 to the other side, x minus 1 becomes n squared. Yes? I don't need to find n, because here I need n squared. So what I do, I just replace it here. So then it becomes y equals to 3 times x minus 1, and that's exactly the same equation. But now the point is that x cannot actually cover all the points. Yes? If I ask you, by the way, that is the meaning of the range. X is a function of n, if you want to understand it in this way. X is a function of n. By changing n, x will change. But what is the domain of this function? Do you remember? Let us repeat these things. This x is a function of n. So this x, so I send it n here. So let me write it in this way. This is a machine. I send n here. I get n squared plus 1 here. That is this function. Yes? Okay, what is the domain of this function? What are my limitations for n? Do I have any limitations for sending any n in?
Well,
yes or no?
it has to be larger or equal to...
No. Domain. Domain are the numbers that I send in. Do I have any limitation for these numbers? No. Because whatever I send in, this can be calculated.
Yes.
So the domain of this function is the set of all real numbers. But what the range is the range still R?
All numbers that are equal to or above 1.
Above 1. So it means that this number is non-negative. It cannot be negative, and I am adding 1 to it. So it means that the numbers that are covered by this function are the numbers 1 or greater than 1. This is why you saw that the x coordinate was always on the right hand side, because the x value is 1 or larger than 1. Yes? And could you predict what happens for this function? Do I have any limitation for sending numbers into this function?
Yes.
Sending in the domain?
Sending in.
No. Yes? What about the limitations for y? What is the limitation for the range? Does the range of this function covers everything?
It's non-negative.
Non-negative. Yes, because 3n squared is non-negative. And that is exactly predicted here. This is the x-axis. Above the x-axis are non-negative values for y. So that is why you could see that. But if I start changing these, if I make this one 2 and this one 3, what do you think it will happen?
Curve.
Then it will become a curve. Yes, and you can find the equation of the curve, even though you cannot realize what that curve is by looking at the equation, but still you can use this trick to find the equation for that curve. Yes, is that understandable? So that is actually a deep question here. I want you to understand. So we started with the bad problem, but we learned a lot about good things. Thank you very much.
But how can that equation be